All right, this example is very similar actually to example 3, except now our displacement graph is curved. It's not made up of a bunch of straight lines. And so we have velocity that's changing over time, right? So there's some acceleration involved. We don't just have constant velocity. So so again, this is just showing you displacement. This S is equal to F of t is just showing the displacement over time. And the first task is just to graph the object's velocity. Now, velocity is the derivative of the displacement, right? So essentially what we want to do is sketch a graph of the derivative of this function. And we've done that before, right? So first thing I would do if I'm looking at displacement over time and trying to graph its derivative, I want to figure out where it's zero, right? So I can see when it's positive and when it's negative, and when it switches direction, it looks like the slopes are passing through zero. So so right up here, I would say the velocity is equal to zero briefly at t equals 3, right? It's the velocity is positive, and then it's zero, and then it looks like, again, the slopes are negative, right? The slope here is negative, so the velocity is negative until you get to like 7, and then it switches direction again. And so at 7, we'll say that v is equal to 0. Now, to me, it also kind of looks like at 0, the velocity is 0, right? Because it's kind of, I see that it's sort of concave up there, and it looks like the slope is fairly flat at those points. And then, the velocity is going to be greater than 0 when the slope is positive. The velocity is less than 0 when the slope is negative. And then over here, it's positive again because the slope is positive. All right, so let's graph. I'm going to first of all graph where I think the velocity is 0. So at 0 and at 3 and at 7, the velocity is 0. Okay, and then the velocity is positive between 0 and 3. So it looks like it just increases and it starts decreasing again. So you have something maybe that looks like this. Oops. I suppose that's good enough. Right? You have something that kind of looks like this, comes down to 0 at 3. And then the velocity between 3 and 7 is negative. So it's hard to know exactly how far negative it is, but I'm just gonna draw a little curve to connect those. And then from after t equals 7, it's just positive again. So it just keeps going, right? So, or at least, well, I suppose I could just draw it just kind of maybe it looks like that. I don't know. So that's a sketch, right? That's a sketch. The key things are that you get that it's positive and negative in the right spots, and you have the zeros at the right spot. All right, so that's just a sketch of the velocity, right? We're just sketching the derivative like we've done before because the velocity is a derivative of displacement. All right, now we'll scroll down here and some questions. When is the object moving to the right? All right, so moving to the right. Now, I think if you look back up here at the description, it says that where does that say that? Displacement to the right. Positive displacement is to the right. Okay, so when the displacement is positive, then that's to the right. Okay, so we're moving to the right, right? We're moving to the right when velocity is positive, right? So so you can see that from the graph of the displacement that we're moving with positive velocity between 0 and about 3. 0 to 3. Okay. Now, and then between 3 and 7, we're actually moving to the left, right? So we could actually write that over here. We're moving to the left between 3 and 7, and then we start moving to the right again. We start moving to the right between 7 and 8. So I'm going to tack that on here. Oops, hang on. All right, between 7 and 8. Okay. All right, so we've actually answered the first two questions. All right. So because our orientation is that movement to the right is positive. So now, when is the object stopped? Now, it never comes to a complete stop. It just it changes direction, right? But we found that from our graph, right? At t equals, I said t equals 0. It's kind of hard to tell there, but it kind of looks like maybe it stopped at t equals 0 and then accelerates, and then it decelerates, stops, and then accelerates in the negative direction, gets back to the origin and goes past it, and so on. So at t equals 0, it stopped. I'm going to say it stopped. And at t equals 3 is where it's changing directions. So it momentarily is the velocity is 0. And at 7, right? And we can tell that, we can also tell that from our graph. That's where we put these the zeros of the velocity, right? So, all right. What is the object's maximum distance from the origin? Now we can tell that from the velocity graph, right? Its maximum distance from the origin. Now remember, it says distance. All right. Now it over here we're 4 units. Does it say what the units are? Meters. Meters. We're 4 meters from the origin. And then down here, we're a negative 5 meters from the origin. But if you're just talking about distance, right, that's the absolute value of displacement. And so the maximum distance is 5 meters. Okay. All right. When is the object moving away from the origin? When is it moving away? All right. So let's think about this. Think about what's happening here. Our distance is positive and our velocity is positive, right? We're moving to the right of the origin and we're moving to the right. So over this interval between 0 and 3, we're moving away from the origin. Okay, and then the displacement is positive and our velocity is negative, so we're moving back toward whatever the origin is. And then down here, between 5 and 7, now our displacement is negative and we're moving in the negative direction. So we're moving away, right? We got back to the origin here. And now we're moving away from the origin. And then we turn around and our displacement is negative and we have a positive velocity, so we're moving back toward the origin. All right, so let me summarize what I just said here. So between 0 and 3, right, we were moving, our displacement was positive and we're moving in the positive direction. So we're moving away from the origin, right? And then we turned around, and between 3 and 5, 3 and 5, stop. Okay. We were moving toward the origin, right? Because our displacement was positive and we're moving in the negative direction. All right. And then between 5 and 7, oh gosh, darn it. 5 and 7, so it's a union there. Between 5 and 7, our displacement is negative and we're moving in the negative direction, so we're moving away from the origin. And then between let me put a union here, between 7, we'll just say, I don't know, 7 to infinity, we could say, because it doesn't, I don't know, it's not, it's hard to know if it just stops there, or maybe we could just say it's like about 8.2, right? At 8.2, we'll just, because that's all that's really shown, that we're moving toward the origin, right? Because our displacement is negative and our velocity is positive. All right. Now, when is the speed increasing and when is the speed decreasing? Those are the next two questions. But let's take a look at our graph here. And remember that speed is the absolute value of the velocity. Right. Now we have a graph here, so we could actually kind of sketch what the absolute value of velocity would look like, right? We could do that. So let me just use a different color here. Let's use this nice blue color. And now, so if the velocity is positive and we take the absolute value of it, we don't have to, nothing changes, right? This here between between 0 and 3, the velocity is positive, right? Take the absolute value of it, it's still positive. Between 3 and 7, though, the velocity is negative, right? So if we wanted to graph what the speed looks like, we could just take the negative velocities and make them positive, right? So we could just kind of draw, let's see, I don't know if let me see if I can draw, trying to match that curve that I have down there below, but you kind of get the idea, right? I'm basically taking all of these negative values down here and making them positive. So if I was graphing the speed, we'd have, this would still be, right, this right here would still be, the velocity and the speed would be the same because they're already positive. But then I have to make this negative part of the graph positive, right? And then beyond 7, it's already positive. Okay, so this, so I could actually, dry that over with. So this blue, this would be the speed. All right, so we can now just look at the graph and look at where the speed is increasing and where it's decreasing. Okay, so it looks like, again, if my graph is decently accurate, it looks between 0 and about 1.5. It appears that the speed is increasing. And also between, again, if I don't know how accurate my graph is, but between maybe 3 and 5, the speed is increasing, right? This part of the graph is increasing. This part of the graph over here between 1 and 0 and 1.5 is also increasing. And then there's another segment over here between 7 and 8-ish, 8.2 or whatever we want to, however far it goes. Okay, so let me summarize what I just said there. I'm going to change back to green here. And so the speed is increasing for t between 0 and 1.5. And again, between about 3 and 5. And then also after 7, 7 to about, say, 8.2, we'll say, right? It's increasing over those intervals. All right, I'm going to move this over a little so it's in the box. Okay. All right. And when is the speed decreasing? Okay, well, we can just look at the slope of the speed graph now, right? It's decreasing. I'll mark it here between about 1.5 and 3, and it's also decreasing here, right? And so we have 2 intervals where it's decreasing. So let me write that down. So I'm just going to say t is between 1.5 and 3, or t is between 5 and about 7, right? Okay, that's telling me where the speed is decreasing. So I just look at its speed, right? So it's the absolute value of the velocity. All right, so when the velocity and acceleration are the same sign, the speed is increasing or decreasing. All right, so the velocity is positive and it's becoming more positive, right? That if it's becoming more positive, the acceleration is positive, then the speed is increasing, right? Okay, I guess I got that. And also, if the velocity is negative and becoming more negative, right? Then, which velocity would be negative and becoming more negative would be negative acceleration. That would also be a case where it's where the speed is increasing. All right, so basically when the velocity and the acceleration are the same sign, the object is speeding as the speed is increasing. And when the velocity and the accelerations are the opposite signs, then what's happening? What's happening to the speed? So let's, in the case of, okay, the velocity is positive, but becoming less positive, right? So the acceleration would be negative. Then the velocity and acceleration are opposite signs. So this, the speed would be decreasing. And also, if the velocity is negative, but becoming less negative, so that if it's becoming less negative, then the acceleration is positive. And so that would be the other case where velocity is negative, but the acceleration is positive, and the speed is decreasing. All right, we got one more example, and I'll meet you there. We'll see you in the next video.